In this video, I want to have a look at the remainder theorem for polynomials. So the remainder theorem says if we've got a polynomial, p of x, and we divide it by x minus a, where a is a number, then the remainder is p of a. Let's have a look at why that works, so the proof of that. So we already know that a polynomial, p of x, can be written as a of x times q of x plus r of x. So our a of x is our divisor, q of x is our quotient, and r of x is our remainder. Now with that a of x, we're going to let a of x equal that x minus a that we're dividing by. So if we're dividing by x minus a, we want to see what happens. So that means we'll just rewrite that as p of x equals x minus a times q of x plus r of x. Now, one of the things we talked about when we first introduced polynomials is that the degree of the remainder always has to be less than the degree of our divisor. So if our divisor here, our a of x, that's just x minus a, that means that our divisor has a degree of 1, which means that our remainder has to be degree 0. Now, if a polynomial is degree 0, then that means it's just a constant term, it's just a number. So r of x, we're going to let that equal k, where k is a constant. So it's just a number, it doesn't have any x's in it, it's just a number. So again, we'll rewrite this line. So we've got p of x equals x minus a times q of x plus k. Now we're going to let x equal a, which means that we're going to have p of a, so we're replacing all of our x's with a's, equals a minus a times q of a plus k. Now a minus a is just going to give us 0, and 0 times q of a, or 0 times anything, will just give us 0. So all that this is going to leave us with is p of a is equal to k. Now k is, where did we write it? Up here. Our k is our remainder. So that means our remainder is equal to p of a. So therefore p of a is the remainder when p of x is divided by x minus a. Let's have a look at what that means with an example. So we're asked to find the remainder when 2x cubed minus x squared plus 5x plus 1 is divided by x minus 3. Now the long way to do this would be to go through and divide this whole polynomial by x minus 3 and actually see what the remainder is once you get to the end of that long division. But using the remainder theorem, we can do this really quickly. So we know that our remainder has to be p of a. So our a is this 3 here. So we're going to find p of 3. So we're going to have 2 times 3 cubed minus 3 squared plus 5 times 3 plus 1. And if we work all of that out, we would end up with 61. So when this polynomial is divided by x minus 3, we end up with a remainder of 61. Our second example asks us to use the remainder theorem to find the value of k if the remainder is 1 when the polynomial x to the power of 4 plus kx squared minus 4x plus 1 is divided by x plus 2. So remember, our remainder theorem said that the remainder was going to be p of a if p of x was divided by x minus a. So in this case, we're dividing by x plus 2, which means that our a, because in our theorem it was a minus here, our a has to be equal to minus 2. We also know that our remainder is 1. So that means that 1 is going to be equal to p of minus 2. So now we can substitute minus 2 into our polynomial and work that out. So we're going to have minus 2 to the power of 4 plus k times minus 2 squared minus 4 times minus 2 plus 1. Going through and working some of that out, we have 16 plus 4k plus 8 plus 1, which would give us 25 plus 4k. So all of that's still equal to 1. Now rearranging that, if we subtract 25 from both sides, we'd have minus 24 equals 4k. And then dividing both sides by 4, we'd end up with k equals minus 6. So that means our k up here in our original polynomial is equal to minus 6. Right, so that's an introduction to the remainder theorem.